Today what we're doing is how do you find the square root of a complex number? So phones up, put your phones up, solitaire, just close it for a little bit of time. You just got to follow what I'm doing and then you're going to be fine. All right. So what we're going to do is how do you figure out what the square root is of a complex number? Okay, now we already know that when you take, what we're trying to do is, if we had we know that when we take the square root, so what I'm trying to figure out here is, what if I multiplied those two, I'm going to get 119 plus 20i. And then these are the same thing, right? These are going to be the same term. So this is going to be the square root. And this is going to be the square root. And when you multiply the two square roots, you should get 119 plus 120i. All right? Okay, now, here's the part that you got to remember. So up front, this is the part you have to remember from the first semester. Okay, so this is a complex number right here. And this is a complex number. All right, when we did multiplying complex numbers, okay, so I'm gonna write this as, this is gonna be a complex number, and I'm just gonna call it a plus bi. Okay, so this is the square root of 119 plus 120i, and this is the square root of 119 plus 120i. And I'm just going to let that be a plus bi and a plus bi. That's the square root. Okay, these are the same thing. Let me write it like this. Bigger. Okay, the square root of 119 plus 120i. And then this is the same thing. Square root of 119 plus 120i. Okay, and instead of writing that, I'm going to say, let these be represented by the complex number a plus bi. Okay, okay, what I've written up there, where it came from. All right, now here's what you got to remember from when we learned about multiplying two complex numbers. Okay, so when I multiply these two complex numbers, the modulus of the new number is equal to the product of the modulus of each one of these. Okay, so if I take the modulus of a plus bi and the modulus of a plus bi and multiply them, I'm going to get the modulus of this term. Okay, when you find the argument of this term, you added the argument of the two complex numbers you were multiplying. All right, so this is what I'm referring to. If you take a complex number and you multiply it by another complex number, okay, the modulus of this product is equal to the modulus of each one of these multiplied. Okay, so if I take a complex number times a complex number, the modulus of the product okay, is equal to the modulus of each one of these multiplied together. The modulus of the product equals the product of the two moduluses, or moduli of the two moduli. So if I took the modulus of this times the modulus of that, it's going to equal the modulus of the product. All right. Then the argument, if I do a complex number times another complex number, remember it rotated it and it stretched it? If you did this, then the argument of the product equaled the sum of the two arguments. Okay, I'll give you a second to write that down. All right, so what we just came up with, guys, was the modulus of the square root is equal to the square root of this modulus. Okay, all right, so you're like, what? All right, the modulus of the square root, okay, so let's do this. If I do the modulus of the square root equals the square root of the original modulus. The modulus of the square root equals the square root of the original modulus. Okay, so let's take this, let's see. We're going to kind of combine all these into just one big thing here. So let's take, so we have enough space here. Let's go Z equals 119 plus 120I. Okay. All right. Now let's find out what its modulus is. Okay, so that would be the square root of 119 squared plus 120 squared. And when you do that, you get 169. So that's the modulus of the original. Okay, now what we said was, I want to take this and do its square root, and that's going to give me the modulus of the square root. So I'm going to do the square root of 169, which is 13. So now the modulus of the square root of z is 13. All right? Then now we want to get what's the angle? Okay, so let's find the original argument. And what we talked about earlier was the argument of the square root is equal to the original argument divided by 2. Okay, so to do that, remember we use the arc tangent. So the arc tan of B over A, 120 over 119. Right? All right, so I'm going to do the second tangent, and it was 120 divided by 119, and that's the degree, roughly 45.24 degrees. I'm just going to estimate this. This is about 45.24 degrees. Okay. All right. Now we want to convert that into the argument of the square root. And the way we did that was we divided it by 2. Okay. So I take this guy, divide by 2, and that's the angle of the square root. So 2262, 22.62 degrees. All right, so what we had here, we had the argument of z. That was 45.24. And then we had the argument of its square root, and that was 2260. And the way that we got these, let's see, this guy we divided by 2 to get that guy. And this one, we did the square root. Okay, so now we can estimate what the square root of this guy is. We're going to use it, we're going to put it in polar form. So polar form means you take the modulus times the cosine of the argument plus sine of the argument I. Okay, so now all we got to do, guys, is drop these guys in. That goes right there. And yep, this guy goes right there. Okay, so we're going to have 13, and this is going to be cosine 2262 plus sine 2262 I. And then you multiply that out on your calculator. Okay, so I'll just do that for all of us here. Okay, so that's my angle right there. So I'm going to use this whole thing so it's more accurate. I'm not going to round it. Okay, I don't know if you know how to store on these calculators, but right here I'm going to say, let's see, store, and put it in number 1. So it just stores it in a drawer 1. Whoops. To enter. Okay, all right. Enter. So I'm going to go 13 times the cosine of this number, 2262. Second, we call alpha A. Whoops, what did it do? And enter. Okay, so that number is really 12. Okay, and then I'm going to do 13 times the sine of that value. Whoops, sorry, keep hitting the wrong buttons. Clear. Okay, I just want to hit alpha A. There we go. It's just putting in that long decimal, that's all. This 2262, and I get 5. So this, when I multiplied these out, when I multiplied this, I got 12. And when I multiplied that, I got 5i. So that's one square root. Now we know when we do square roots, they're opposite of each other. So then the other square root is the opposite of this, which would be negative 12 minus 5i. And these are the two square roots of 119 plus 120i. One square root is this, and the other square root is its opposite. Okay. So first thing, get the modulus of this guy and get the argument. Okay, so this would be the square root of 1 plus the square root of 3 squared. This would be the arctan of b over a. Then when you put that guy in the calculator, here, arctan square root of 3 over 1 square root of 3. Okay, enter. 60 degrees. Okay. All right. Now, to convert these, you're going to take these two things and change them into the modulus of the square root and the modulus and the argument of the square root. So I take the square root of this to get the modulus, and I take half of that to get the argument. Okay. So let's see. I'll let this just represent z. So this was the original. Let's see, the modulus of z was 2, and the argument of z was 60 degrees. Okay. All right. Now we want the square root, the argument of the square root, or the modulus of the square root and the argument of the square root. Okay. So what's my modulus going to be? What do you do to this one to get that one? Square root it. What do we do to this to get this one? Divide by 2. Okay. So we square root this, take the square root, and this one divide by 2. Okay, so now we're gonna write our, so this is root 2, this is 30 degrees. Okay, so now I can write my square root. It's gonna be, the modulus is root 2, cosine 30 degrees plus sine 30 degrees I. Root 2 and 30. Okay, and that's equal to the square root of 2. Cosine at 30 degrees is root 3 over 2. Sine at 30 degrees is 1/2. And now we just distribute. Root 6 over 2 plus root 2 over 2i. That's one square root, and then the other square root is the negative of that. Okay, all right. Let's see if we can streamline this now. Okay, so let's start with 5 plus 12i. Okay, let's do its modulus. This would be 5 squared plus 12 squared, and that ends up being 13. And then the argument is going to be arctan 12 divided by 5. And that's that long decimal right there. So I'm going to store that. I'm going to go store alpha A. It just puts it in a drawer called A. All right. So 6738 roughly. All right. Now let's do the square root. 5 plus 12i. Okay, so what we did was we took this and we took its square root. And then we took this one and we divided it by 2. Store alpha A. Okay, so 3369. Okay, and now you can write out your answer. Let's see. Root 13 times cosine 3369 plus sine 3369i. And now I'll just multiply all that out. Oops. Okay, so let's see here, square root of 13. Root 13, okay, times cosine alpha A 3. So that's 3 plus, okay, square root 13 times the sine alpha A, and that's 2. So there's one square root, and then the other square root is its opposite. All right. So it's it's pretty straightforward. So really, if you just kind of focus on this process right here, and then the 13 went right there, and the 3369 went right there. Okay, so your assignment for this, guys, are the first 3 problems on the student section here. So you're doing that guy, and that guy.